All right, so now what we're going to do is work on finding all of the zeros when given a zero or a factor. Now, this is very important because in the previous examples, looking at division of synthetic division and long division, what we understood is if we had a factor that evenly divide into a polynomial, that gave us another factor. And if we can have multiple factors, the product of that gives us that original polynomial. And this is helpful because when we can't actually factor something out, if we can use division to rewrite that polynomial as a product of its factors, we can then use our zero product property to solve for all the zeros, as well as identify the multiplicity. So that's exactly what we're going to be looking at, is taking a polynomial when given a factor or a zero, and then go ahead and finding all the remaining zeros and writing it in linear factorization form. And again, the factorization form is so helpful because that way we can quickly identify the zeros as well as the factors. Now, I do have two kind of theorems up here, the factor theorem and the remainder theorem. And we're going to talk, a little bit, more into these later, but I just wanted to address them at this point. And basically saying that, something is a factor. And, really, when looking at it, at least in our example, something is going to be a factor when the remainder is going to equal 0. So when we have an expression, a divisor, and it evenly divides into another polynomial with the remainder of 0, then that is going to be a factor. And another way to look at that is by this factor theorem, that if we take the factor and then take k, which would be the 0, if we plug that into the function and we get a 0, then that tells us that's going to be the remainder. And since that remainder is 0, therefore, we have a factor of the polynomial. And the remainder theorem is very connected with that. It's basically saying whenever you take your factor or a possible factor, take that k and plug it into your function. If you don't get 0, well, then obviously it's not a factor, but therefore whatever number you do get is going to be your remainder. So I wanted to kind of bring that up there. We can check it, for instance, over here. So for instance, let's just kind of check it in this example. So if x minus 1 is my factor, and if I want to test to see if this is a factor, then all I need to do is find the 0. So that means you can set it equal to 0, and therefore x equal to 1. Now, I'm doing it for this polynomial, by the way. So now let's plug in 1 in for that polynomial. 1 cubed minus 4 times 1 squared plus 5 times 1 minus 2. And you can see here that we get 1 cubed is 1, 1 squared is 1 minus 4, plus 5 minus 2. And therefore what we get is we get 0. Now again, I already told you this is a factor, so you already know this is a factor, so this has to be true. So therefore that's why, that's going to work. Now I'm not going to go through to the division. We do that in, actually let's go through a polynomial where we had a remainder. Let's see, here 13. So if you were to go ahead and plug in a -3 into this polynomial, so here's your factor, -3. If you were to plug that into the polynomial, let me write that x cubed minus 2x squared minus 5x plus 7. All right, so x minus 3. Let's go ahead and plug that in there. So we know that by division, when this divisor divides into that, we get a remainder of 13. So let's see if that works by using the remainder theorem, by basically plugging that in. So we have x minus 3, so set equals 0. That means the 0, or the k, is going to be 3. And then we would plug that into that equation, which I rewrote, which is 3 cubed minus 2 times 3 squared minus 5 times 3 plus 7. So as long as I do my math right, I'm going to go ahead and get 13 for an answer. So 3 squared is 27. 3 cubed is 27. 3 squared is 9 times 2 is 18. -5 times 3 is a minus 15. And then plus 7. All right, so let's kind of combine these here. This is going to be 9. And then -15 plus negative, let's see, what am I doing? -15, did I have that right? X cubed minus 2x squared minus 5x plus 7, x plus 3, did I do that one right? 1, times 3, negative 2. Oh, crap. That's a negative 6. That should be a 1. I knew I was good. Good thing I caught that. So negative 2 times 3 is a negative 6. That becomes a remainder of 1. So actually, I should get a remainder of 1. Good thing I caught that. I caught my mistake. Because I'm looking at this and I say, well, that becomes a negative 8, which equals a negative 1. Right? And that's the remainder that I caught my mistake on back over here, that negative 1. So that's how the remainder theorem and everything works. So it's just important because we're giving these factors and these zeros. You know, if you need to test them out to see if something's a factor, see if something's a zero, you can use the factor theorem. Plug in the k into your function, and if you get 0, it's a factor. If you're just looking for the remainder, plug that value in, and whatever that number is going to be the remainder. All right, so now let's get on to example number 4, and I have a couple of these that we are going to kind of work on, and we're going to use division, and we're going to use long division as well as synthetic division to find all the zeros and then write the linear factorization. Now, remember when I was talking about synthetic division, I think synthetic division is, very helpful, especially when we're given linear factors. So for everything that I'm given a linear factor, I'm going to use synthetic division. However, it's not always the best, and we'll look at some examples of why it's not going to, when it would be preferred to use long division. In this example here, I have x minus 1 is going to be my factor, so therefore I know positive 1 is my 0. So I'll write that on the outside. I make sure that my polynomial is in descending order, which it is, so I take my coefficients and write that on the outside. Now I bring down my 1. 1 times 1 is 1. Negative 4 plus 1 is negative 3. Negative 3 times 1 is negative 3. 5 plus negative 3 is 2. 2 times 1 is 2. And that gives me a remainder. And again, the important thing about this is, when we look at this, if you don't get a 0 and it tells you that's a factor, then you did something wrong. So you're going to want to go back and check your answer. So this is my remainder, or this is my quotient here. So if I wanted to, again, write this as my quotient, you'd have your remainder, constant, linear, quadratic. Now, I'm not going to do this for the rest of them, so I'm just going to do this one more time. So the quotient is x squared minus 3x plus 2. And what really happens, what's important here, is if I want to find the zeros of this polynomial, right, I would set this equal to 0. And then I would try to see. Well, the problem is I can't factor this polynomial. I don't have any factoring techniques to be able to factor this. However, if I know that this is the quotient when I divide this polynomial by x minus 1, that means I can rewrite this polynomial as a product, just like what I did at the beginning. If I know that that factor divides into it, let's get in there. If I know that 3 divides into 12 4 times, then I know that 3 times 4 equals 12. So I know, stop that. I know in this case that x minus 1 divides into this polynomial x squared minus 3x plus 2. So therefore, I can rewrite this polynomial as x minus 1 times x squared minus 3x plus 2. And if I'm trying to find the zeros, I'm setting the polynomial equal to 0. Well, I'm going to set it using my linear product factored in 0. And again, when we want to write this as a linear factorization, we need to continue factoring these down. So now I see this as a quadratic trinomial and say, all right, can I factor this? What two numbers multiply to give me 2, add to give me negative 3? And what I notice is I have x minus 1 times, let's see, x minus 1 times x minus 2. Okay, now that's going to help me out. I can find my zeros from here, but it also said to write this as a linear factorization. You can see that x minus 2 is repeated. So without writing it as with the zeros, I could write this as x minus 1 squared times x minus 2. Okay, and so what's important by simplifying this, you can see that 1 has a multiplicity of 2, right? And then also I have my 0 here. So if I'm going to write my zeros, I can write my 0 is going to be a 1 with a multiplicity equal to 2. Sorry, I'll zoom back in. Multiplicity equal to 2, and then comma 2. Okay, so those are going to be my zeros for that polynomial. All right, let's work for the next one. The next one I'm already given 7, so awesome. It's already written as a 0, so I'll just put it on the outside. And then I'll take my coefficients, which would be 2 15, 4, and negative 21. I don't have any missing terms, so that's awesome. Bring down the 2. 2 times negative 7 is going to be a negative 14. 15 plus negative 14 is 1. 1 times negative 7 is negative 7. Then I have negative 3. Negative 3 times negative 21 is positive 21. Awesome. Sweet. So therefore, again, now I can rewrite this as a product. So if this is my 0, that means x plus 7 is my factor. Okay, so I'm going to immediately write it that way. So I have x plus 7. And then this is remainder, constant, linear, quadratic. So I have 2x squared plus x minus 3. All right, so now I have to factor when a is not equal to 1. Let's see here. I could multiply. Let's see how this is going to be factorable. So I can have x plus 7. Let's see, you're going to have a 2x and an x. So therefore, I need them to multiply to give me negative 3. Okay, I got it. So why don't I do a negative 3 and a positive 1? So let's see, that gives me negative 3, but this gives me a negative 6x, and that gives me 1, so that doesn't work. So that's close, but I got to switch those around. I think if I switch these around, that will give me what I need. So why don't we do a negative 1 and a positive 3. All right, so again, let's check it. 2x times x is 2x squared. 3 times negative 1 is negative 3. 3 times x is 3x. 2x times negative 1 is negative 2x. 3x plus negative 2x is a positive x. Sweet. Now I have everything written as linear factors. I could write this as linear factorization, like the y. You know, x plus 7 times 2x plus 3 times x minus 1. But if I'm trying to find the zeros, I would keep it set equal to 0, and I can just write my zeros as negative 7. Set this equal to 0 would be, if you're to set that equal to, remember you set all of these equal to 0, so 2x plus 3 equal to 0, so therefore x equals negative 3 halves. So I'd have a negative 3 halves, and then a positive 1. All right, now let's get into another example. Now, in this case, I have an x squared minus 5 as my factor. So could I actually use synthetic division? And the answer is actually yes. You could, but you can only do it when you have a linear factor, meaning I would have to factor this further down into just like what we kind of talked about. So you could do x minus square root of 5 times x plus square root of 5. And then you could do synthetic division. But I think when you practice with synthetic division with both of these, what you'd have to do is you have to do synthetic division twice. You'd have to do it with negative square root of 5 and plus square root of 5. And doing synthetic division with complex numbers and irrational numbers is not really that much fun. So when you have a factor or even like one of these radicals, I would just prefer using long division. And that's the way that I'm going to do this problem. So I'm just going to set this up because I see that it's not linear. So I'm like, you know what? I'm not even going to bother with it. I'm just going to do long division. So I have x to the 4th minus x cubed minus 7x squared plus 5x plus 10. All right. So how many times is x squared divided into x to the 4th? Well, that goes in there, x squared times. X squared times x squared is x to the 4th. X squared times negative 5x, or negative 5, is a negative 5x squared. Subtract the rows. I can bring down the negative x cubed. Negative 7x squared minus a negative 5x squared. That's going to be a positive, so that becomes a negative 2x squared. X squared divides into negative 2x squared, negative 2 times. Negative 2 times x squared is a negative 2x squared. Oops, sorry. Wait a minute. What happened here? What did I just do? I just started talking and I started thinking about something else. So I subtract these. All right. Sorry about that. I was mixing up my things. Okay, so I subtracted them. Done. You got to go into this. I went over there. X squared divides into negative x cubed, negative x times. Negative x times x squared is a negative x cubed. Negative x times negative 5 is going to be a positive 5x. So I probably need to bring this down to subtract it. All right, subtract my rows. These are exactly the same, so they divide out. You bring this down, negative 2x squared. X squared divides into negative 2x squared minus 2 times. Negative 2 times x squared is a negative 2x squared. That goes to 0. And then negative 2 times negative, what am I doing? I'm like scatterbrained. Sorry about that. Subtracting these, subtract this goes to 0, that goes down, and then you can just bring down the 10. All right, now x squared divides into negative 2x minus 2 times. I forgot to bring down 10, subtract those. I'm sorry. Negative 2 times x squared is a negative 2x squared. And negative 2 times negative 5 is going to be a positive 10. Okay, and when you subtract those, you again get 0. Now, it is helpful to remember that I wrote that as x minus square root of 5 and x plus square root of 5. And if you didn't understand where I did that, you could also look at that just by setting the factor equal to 0 and then solving, right? And then taking the square root of both sides, and you get x equals plus or minus square root of 5. So that's another way to get those two zeros. And then we look at this, we say, all right, well, how can I, solve x squared minus x minus 2? Like, can I rewrite that? Because basically, this polynomial can be rewritten as this product. So let's rewrite that. Let's set it equal to 0 to set it equal to y. And therefore, I would have, so that's really x squared minus 5 times x squared minus x minus 2. But if I want to write this in linear factorization, that means I need to rewrite this as a product of linear factors. So that's x minus square root of 5 times x plus square root of 5. This is going to be, let's see, what two numbers multiply to give you 2, add to give you a negative 1. That would be x minus 2 times x plus 1. Okay? And now you can see that I can set this equal to 0 and then set each and every factor equal to 0 to find my zeros, which is just going to be plus or minus square root of 5, comma 2, comma negative 1. All right, now let's get into the next example. Now the next example is kind of interesting. It now gives you a 0. Now there's a couple different things to understand about this. If it gives you a positive radical, we know that the conjugate has to exist. So we know that x equals negative 2 square root of 2 also has to exist, right? So therefore you can do synthetic division with the radicals. But I do not want to do synthetic division with the radicals. So what I'm going to do is I'm going to write each 0 as a factor. Just as we can write factors, as zeros, we can write zeros as factors. So we practice that with writing the equation. So what that means is I can rewrite this as x minus 2 square root of 2 times x plus 2 square root of 2. And if I can use a factor, then what I can do now is I can use long division instead of synthetic division. So let's do a little multiplication here. So therefore, that's going to give me x squared plus 2x square root of 2. Oh, I don't need to worry about, might as well. Minus 2x square root of 2. And then, let's see, that's going to become a negative 4 square root of 2 squared. Oops, let's put that out on the outside. No, 2 squared, yeah. It's on the inside. All right, so this is difference of 2 squares, so hopefully you would notice that these middle terms divide to 0 anyways, and you're just left with x squared, those goes to 0, minus 4, and then 2 squared, if you think about that, 2 squared is 4, square root of 4 is 2, so therefore it's really going to be x squared minus 8. Okay, so that's my factor. Those are my zeros, that's my factor. So now what I'm going to do is I'm just going to set up long division. X squared minus 8. And I was going to do long division. X to the 4th plus 2x cubed minus 7x squared minus 16x minus 8. All right, so let's use a different color just to switch things up. X squared divides into x to the 4th, x squared times x squared is x to the 4th. X squared times negative 8 is going to be a negative 8x squared. Just make sure you align these. Don't put the x squareds under here. Subtract my rows. That goes to 0. I can bring down the 2x cubed. Negative 7x minus a negative, that turns into positive, so that becomes a positive x squared. And then let's bring down the negative in 16x. I didn't do that last time, so let's do it this time. All right, so now let's do it again. X squared divides into 2x cubed. Let's see, that's going to be a plus 2x times. 2x times x squared is going to be a 2x cubed. 2x times negative 8 is going to be a negative 16x. All right, and then let's subtract the rows. That goes to 0. That brings down. Don't really need to bring the addition sign. Okay, that becomes x squared, and that goes to 0. So then let's bring down the 8. Okay, x squared divides into x squared 1 times. 1 times x squared is x squared. 1 times negative 8 is negative 8. Those subtract to give you 0. So again, I can now rewrite my polynomial as y equals x squared minus 8 times x squared plus 2x plus 1. Right? Now, if I want to write my linear factors, I don't really need to go too much far. I need to factor this, right? But also, I already have my zeros written as linear factors, so that's not too bad. I can go and do that rather quickly. That's kind of nice. Oops, didn't mean to do that. So therefore, I'd have y equals, let's see, that's x minus 2 square root of 2. And this is going to be x plus 2 square root of 2. This is saying what two number multiplied by itself gives you 1 and add gives you 2. Hopefully you understand that's x plus 1 times x plus 1. So therefore, it's x plus 1 squared. That's important because now when I'm writing, that's my linear factorization. But when I write my zeros, I can write plus or minus 2 square root of 2, comma, another 0, negative 1, but with a multiplicity equal to 2. And again, I'm skipping the zero product property because that's something we've gone over multiple times. All right, I think we only got 2 more, right? Yes. All right, last 2 ones. So in this case, we're given zeros, negative 3 and 3. Well, you could also write that as x equals 3 and x equals negative 3. But regardless, what we're going to do is apply synthetic division. Well, what's nice about this is, usually once you get to synthetic division, we want to see if we can find the zeros. But if you can't, then you can do synthetic division again, or try it again. So let's see how this works. So in this case, let's start with 3. So I start with 3. And I have 1, negative 1, negative 10, 9, and 9. Bring down the 1. 1 times 3 is 3. That becomes a 2. 2 times 3 is 6. Negative 4. Negative 4 times 3 is negative 12. Negative 3. That becomes a negative 9, 0. All right, so this ends up giving me a quotient of, I always like to work backwards, so 0, so that's remainder, so that's constant, linear, quadratic, cubic. So I have x cubed plus 2x squared minus 4x minus 3. Now, I can't factor this further down. I can rewrite the 0 times this as a product, but I can't further factor this down. So what I'm going to need to do is I'm going to need to use synthetic division again, but now with my other 0. Because right now I can't solve this. Like I can rewrite this as a product and set it equal to 0, but I don't have a technique to solve in this. So now I'm going to take negative 3 and use that 0 to further factor down the next 0. So now I bring down the 1. 1 times negative 3 is negative 3. That becomes a negative 1. Negative 1 times negative 3. And negative 1 times negative 3 is a positive 3, which gives you a negative 1. Negative 1 times positive 3 is going to be a 3, which gives you a 0. All right, so now I'm getting x squared minus x minus 1. Well, great. This isn't even factorable anymore. So guess what? Now I can rewrite this. Now, again, it's kind of important. If I was going to write this as my linear factorization, y equals, I have my 2 zeros, I'll write as factors, and then times x squared minus x minus 1. So the good news is I can rewrite down to a factor that's a quadratic. So I know at least I can, that's better than having a cubic, right? That's why that's a nice thing doing the synthetic division. The bad news is this is non-factorable. So if it's non-factorable, guess what I got to do? Good old quadratic formula. So yeah, you're like, yeah, I know. Well, guess what? I'm going to do it so you can take advantage of that. So x equals opposite of b, which is 1, plus or minus the square root of 1 squared, which is 1. Or I'll just write in there. So b, opposite of b. So opposite of -1 plus or minus -1 squared minus 4 times, come on, I hate you, minus 4 times, let's zoom in here, minus 4 times a, which is 1, times c. I'm going to do a lot of math in my head for this. Divided by 2 times a, all over 2 times a. All right. So as we move on with this, opposite of -1 is 1. Plus or minus, I'm going to do all of this. So -1 squared is 1. All right. And then I have a -4 times a -1, which is positive 4. Positive 4 plus 1 is square root of 5. Divided by 2. Okay. Wasn't that bad. Now I can rewrite this as 1/2 plus or minus 1/2 square root of 5. Basically, I'm taking the 2 and dividing it into both of those terms. Instead of rewriting this as square root of 5 over 2, I'm just writing it as 1/2 times square root of 5. So now I can write it as my linear factorization. So y equals x minus 3 times x plus 3 times x, let's see. So x minus 1/2, x minus 1/2, x equals this, so minus 1/2 plus or minus, or, oh yeah, I got to do both these factors. Okay, so plus 1/2 square root of 5, and then x minus 1/2 minus, minus 1/2, yeah, minus 1/2 square root, square root of 5. That is a messy problem, but that's okay. That works. All right. Now, if I just want to find my zeros, I'm just going to use plus or minus 3, and then I'm going to use 1/2 plus or minus 1/2 square root of 5. 1, 2, 3, 4. 4 zeros. Do I have 4 zeros there? Yep, perfect. All right, well, that's it. That's how you can use division both ways. And just remember, guys, sometimes everything's not factorable, so using the quadratic form is going to be helpful. Hopefully this last one is not so bad. Again, here we're given another factor, so I'm going to start off with using long division. So let's see, 2x squared minus 3. I hope I wasn't that mean to myself picking these problems. 2x to the 5th minus 8x to the 4th minus 5x cubed plus 12x squared minus 12x. All right. So 2x squared goes into 2x cubed. X cubed times 2x squared is a 2x to the 5th. X cubed times -3 is a -3x cubed. Subtract our rows. That goes to 0. Bring this down. That minus a negative, that becomes a positive, so that becomes a positive 8x cubed. 2x squared divides into negative 8x to the 4th. That's going to be a negative 4x squared. Negative 4x squared times that, it becomes a negative 8x to the 4th. And negative 4 times x squared times -3, it becomes a negative 12x squared. So let's bring that down. Okay, subtract the rows. That goes to 0. Bring that down. 8x cubed. That goes to 0. So let's bring the 12 down. 2x squared divides into 8x cubed. That'd be a positive 4. Positive 4x. Oh, I guess I forgot to show that. Yeah, well, 4x times 8x squared is going to be an 8x cubed, and 4x times negative 3 is a negative 12x. Okay, I guess I was like so tired from doing all these problems, I forgot to notice that I could have easily factored out an extra x, right? I could have factored out an x here and found that, and that would have been one of my zeros. But I did the math without it. Doesn't matter. So anyways, I have this factor and this factor. And now let's go and write these as our linear factors. So I have y equals, so 2x squared minus 3 times x cubed minus 4x squared plus 4x. Okay, so again, we need to write this as a product of linear factors. So by doing that, this is not really as fun, so you might want to like solve this to the side. So 2x squared minus 3 equals 0. Add the 3, divide the 2. So you'd have x squared equals 3 halves, square root, x would equal, plus or minus the square root of 3 over square root of 2. And sometimes people will rationalize the denominator as well. So you multiply by the square root of 2 on the top and bottom, and you get a final answer, or simplified answer of x equals plus or minus the square root of 6 over 2. So technically, if you just left it as square root of 3 over 2, that's right. But if you're looking at like multiple choice questions, something like that, you'd want to see that written as a square root of 6 over 2. And that's how I'll write my answer. So anyways, those are the zeros. So if I want to write those as the factors, I'd write this as x minus square root of 6 over 2 and x plus the square root of 6 over 2. I can factor out an x here. So when I factor out an x, I'm left with x squared. So if I factor out an x, I'm left with x squared minus 4x plus 4. Well, I notice that's a perfect square trinomial, x minus 2 squared. So I can write my zeros here, and that's the linear factorization. You should probably put the x in front, but that's okay. Linear factorization is going to be plus or minus the square root of 6 over 2, 0, and 2 with a multiplicity equal to 2. All right? So I don't know why I'm squaring that. Either way. All right, so there you go, ladies and gentlemen. That's at least how you find the zeros when given a zero or a factor. And I think it's just important just to remind you that, sometimes long division is the best, sometimes synthetic division is the best. If you have synthetic division and you get a quotient and it's not something that you can further solve, then look to use another zero to further divide it. And again, even if you get it to a quadratic and you can't factor it, make sure you remember using the quadratic formula. Whenever we're given something with radicals, or second power, it's preferred to, multiply them together to get a divisor that's quadratic, so therefore you can use long division. But hopefully all these steps kind of helped you out as far as identifying them and further finding the zeros. Now let's wrap up this lesson by writing the equation of the polynomial and using the theorems that we first talked about.